Welcome to this video on exporting detections and environment data from FPOD files. So let's dive straight in. Um, Here is 30 days out of nearly twice that long. Um, and what we've got here is the kind of normal settings of looking at high and moderate quality click trains, high species confidence only, and these three narrowband high frequency other cetaceans, dolphins and sonars are selected, although in fact what I'm going to show you for the exporting will automatically set up those three. When we look at the data here, you can see that there's a lot kind of happening in the environment here. These angles are swinging around quite dramatically, going almost flat and then almost vertical. It's probably a tidal cycle. There are some big lumps of noise here associated with changes in the sound spectrum, which will be due to actually sediment transport, fine sand in this location. And we've got a lot of sonar detections and a few dolphins and porpoises, and there are more later on. Anyway, we're going to export the data, so we show the menu, we go to the export page. Oh yeah, so we want this one, detections and environment, and say we choose to get the figure for every hour. It's probably not generally useful to get detections environments on like 1 minute scales. The temperature, for example, um, moves very slowly. The sensor is deep inside the pod, so it takes quite a while to respond. So hours or days is often a good unit to be looking at. We're going to export to results. If you're exporting a big batch of files, you want to do it to a text file because that's quicker. And we're using a tab separator so we can drop it straight into Excel. But if you're wanting to put your data into R, you might want a CSV file, etc. So you can work your way through all these, and when you sort of hover your pointer over each thing, some kind of helpful notes appear at the top of the screen. So we will export data from file 2, which is an FP3 file, and whiz bang, it's done it. Yep, it's actually done that in real time. It's read the whole file, put it on the results page. I do cut to clipboard and then get a spreadsheet up. So here's the spreadsheet, Control and V to drop it in. So I'd actually preset these graphs here so that we can see the results more quickly. So over here, we'll just look at the column headings. You've got the file name, the site code. Um, there aren't any in this file. They're useful. You can add them to files. They're useful primarily in projects where you've got a number of sites you're monitoring. Pod number, chunk end. So we're looking at hours. So that's the last minute in each hour. The minute number, that's since the first minute in the year 1900. The temperature, the angle, the minutes on. So the first hour it was only on for 17 minutes. After that, it's 60 minutes an hour. And then we've got the DPM for porpoises, the number of clicks for porpoises, same pair of things for dolphins, same pair for dolphins, and then N all per minute. So that's the number of clicks per minute. So here's the angle plotted out, and you can see here what we saw on the graph, that it practically goes flat. Flat would be 90 degrees, 0 would be vertical. So this one's swinging around a lot, and you could see kind of how much that's correlated with detections. The temperature is kind of high when it's in the boat or at home or somewhere. Then it drops down to sea temperature and slowly rises through the season. Um, if we're looking at measures of noise, you've got the number of all clicks per minute, and there they are. But you've also got this thing, which is that column U there, the average operational threshold. So actually, if you want an index of noise, this is the better one to use, because what the pod does is if it has a small number of minutes, which you can control, but it's normally set at 3, um, which exceed a certain level of number of clicks, it pushes its operational threshold up, which particularly knocks out weak short clicks. So it doesn't affect porpoise detections too much. And it actually doesn't affect dolphin detections too much either, but it gets rid of some of this noise. So that's actually a better measure of the noise levels going on than number of all per minute. And then time lost, which was column P here, is the maxing out issue. So in a minute, the maximum number of clicks the pod will record is 2 to the power of 14. It's 16,384. And those are the minutes, the hours, sorry, in which any time has been lost by that maxing out. And that's a percentage figure. So in a small number of hours, up to 2% were lost, which would basically be 1 minute, wouldn't it? Yes. Um, okay. And then there are columns for the sonar risk. You can, of course, get actual sonar values. You know, we've got them here, sonar DPM. So let's just quickly graph that. And that's probably the better one to use generally, but you can investigate sonar risk. Sediment noise, that's sort of basically any continuous noise source, and sediment transport is by far the commonest. That can be interesting. Landmark sequences, that's if you've actually got the software to look for them in porpoise click trains. Um, Percentage minute watts risk, that's weak unknown train sources. We've got a video on that. Quite honestly, I wouldn't pay too much attention to that yet. We need to do a lot more work on these horrible things. Um, so if you then decided you wanted to look at a somewhat different set of data, you know, you wanted, say, to filter for fast click trains, you can set up your filter here. So you might say it's got to be 100 clicks per second upwards. And then when you get to export, you just do DPM, say, or number of clicks, whichever you want, or you can do each in turn per hour. And you export that from file 2. And you get this set of data, which you can drop in next to the one you've already got, and it'll line up. And the thing you've got to do is label the relevant column. When you've got it all lined up, it'll be this one here as to what it is. So it's like fast NBHF DPM or whatever. Okay, I think that's about it. And then when you've got it in your spreadsheet, you can have a lot of fun working out what's actually happening in the sea. Um, so thank you for your attention, and do let me know if any of this is horribly unintelligible.